Could you divide by cos 2x on both sides?
Do you know what tan divided by cos is?
No.
Me neither. Let's see. What is tan the same as?
Tan.
Yep.
It's same as sine over cos.
So tan 2x, sine 2x over cos 2x. Okay, any idea what you'd do next?
So could you write it as tan as sine? Instead of tan, you could write it as sine 2x over cos 2x.
Yep, same thing.
Okay. I think you do 4 sine 2x over 4 cos 2x.
Well, the left side is divide by cos 2x. How would you get rid of the fraction?
You'd multiply by cos 2x.
Yeah. And so what would you get?
Would you multiply it by on both sides?
Yeah.
Okay. Minus, well, I got a bunch of random numbers.
There's no numbers. What is
Oh, right. The left side would just be sine 2x.
sine 2x? Right side?
The right side just be 4 tan. Oh, no. 4 sine 2x cos 2x.
Yeah. Okay, let's see. There, R1. Theirs is equal to 0. Let's make R1 equal to 0.
Do we want to make the right equal to 0? Or does it matter?
It doesn't matter. Let's do that because that's what their one is.
So, do we just divide by 4 sine 2x cos 2x on both sides?
You minus.
We just minus it. Okay. So you get sine 2x minus 4 sine 2x cos 2x.
Mm-hmm. And after that?
And then you turn sine 2x into 1 minus sine 2x.
Factorize.
Factorize.
What do they have in common?
They all have 2.
What else?
4.
No. In between
X.
the minus sign. What do these two?
Sine and sine.
Yep.
So it'd be sine, just sine.
It has to be sine of something.
Sine just sine x. No.
What else?
Sine 1x.
No. More than that. What do they have in common?
2. 2x.
Yes, there you go. They both have sine 2x.
Oh, and then we just put 4 sine.
Factorize.
2 sine.
Sine 2x times what gives you sine 2x?
Sine.
No. Sine 2x times what gives you sine 2x?
1.
Yes. 1 minus, and then factorize out sine 2x from the second one.
Four cos.
Yeah,
And then 2x.
that's it. That is it. Okay, part B.
Okay.
Any idea how to start the next one?
So I've got it to sine 2x equals 4 sine 2x cos 2x. Is that right?
No. How would you solve this one?
So they want the numbers between 0 and 180.
Sure. How would you solve this one?
Would you multiply a by everything in the bracket?
You probably would. You can also do a equals 0 or 1 minus 4a equals 0.
Okay.
Something similar for this one.
So it'd be a equals, it would be sine 2x equals 0 or sine 2x equals
No.
1 minus 4 cos 2x.
Either sine 2x equals 0 or 1 minus 4 cos 2x equals 0.
Yeah.
And then you would solve those.
Okay. So for sine 2x equals 0, would that be 0?
So one solution is 0.
Yep.
Any other solution?
No, would it be 3? I think.
How'd you get 3?
Wait, you know, for the 4 cos 2x bit, would the 4 need to be divided? Or would it just need to be...
Divided.
Okay, so the answer would be minus 1.
Let's see. So if you were to rearrange the one on the right, it would be 1 equals 4 cos 2x.
Yeah.
And so what's cos 2x equal to?
A quarter.
Yep.
And then you can do inverse cos on both sides.
Yep.
So you inverse cos a quarter, which is 75 or 75.522 degrees. And then you divide it by 2, which gives you 37.8.
Hold on. Yeah, you would let that be equal to a.
Yeah.
Then you'd get all your solutions. How do you get next solution for cos?
Is it you take away 75.5 from 360?
Yep.
Which gives you 284.5.
And what do you do with those two answers?
You can figure out higher or lower. You add on minus 180, right?
Tell you what, we'll do it all at the end. This one up here, we got one solution, sine 2x. So we said x is 0.
Yeah.
How do you get another solution? Actually, we'll make it like a is 0.
Okay. Well, we know it's sine, so we can minus 180 from it.
Yeah.
So one of the solutions is a 180. Minus 180.
Yeah. And it's a very, very special one. X is between 0 and 180. What is 2x between?
So would you would you half the answer?
Yeah. But hold on. What is 2x between if x is between 0 and 180?
Oh, okay. It would be 0 and 360.
That's it. And so can we get one more answer with sign?
Could you add 180?
That's 10.
Minus 180, sorry.
Still 10. So your two answers only ever add or subtract 360.
Okay. So would you add 360? Oh, yeah, because the first one you add 360, it gives you 360.
Yeah, so that's like, it's a very special
Yeah.
one that you got 3 answers for that. I mean, 0, special number. Okay, so that's what A is. A is 0. It's also 75.5.
Yeah.
It's also 180. It's also 284.5. And it's also 360, smallest to biggest.
Yeah.
We want X. And A is 2.
So then would you divide them by 2?
Yeah.
Okay. So the first one would be 37.8.
And what would be the other one for
2.8.
cos?
It would be 142.3.
Okay, so hopefully they rounded correctly because I rounded them too early. 37.8, 142.3. So that's why you don't round it too early. It's my mistake. I should have insisted. I thought it would be the final answer already. And then the other one was 0, 90, 180. 0, 90, 180, because that's half. Great.
Yeah.
So the reason why I threw this in was because this tan business, tan is sine over cos. You then multiply through by the denominator, and then you bring them together and factorize. All right.
Yeah.
Any questions there?
Nope.
Okay, let's see. Equations and identities. More tough stuff. All right. Let's try. Silly me. Let's try question A.
Okay. So would you need to move things to the right side of the equation first?
No, nothing wrong with it. What I would do is the smallest one, like in this case, you have cos squared and cos. I would say let cos theta be equal to A. And so what would it become then?
2 cos squared theta.
No, cos theta is A.
So 2a squared.
Yeah.
Minus a minus 1.
How would you solve that for A?
Would you divide by 2 on both sides first?
Sing us a song, Mr. Calculator Man. Sing us a song through the night.
Oh, it's quadratic, isn't it?
Yep.
So would A be 1? Could you just use it as 1?
A is A. So, so little a is 2 equals -1 equals -1 equals.
I got x is 1, x2 is -1/2.
Okay, so a equals 1 or a equals -1/2.
Yep.
And now use that to solve for theta. We unlet cos theta and a. So instead of a, it's cos theta is 1.
Yeah.
Cos theta is -1/2. And so solve those.
Okay. You would do inverse cos on both sides.
Yep.
So the first one would be 0. And the second one would be 120 degrees.
Can we get more answers between 0 and 360?
Yeah, we can add 360 to both, to the left.
Yep. So theta is 360.
Yeah.
How about the other one?
Could you do 360 minus 120?
Yeah.
Which gives you 240.
And so what are our solutions for theta for part A?
0, 120, 240, 360.
Well done. And it can be useful to do them smallest to biggest. Great. Do I have this here? 0, 120, 240, 360. Let's see this one. Ooh, they get weird. Oh, they do. They don't.
Okay.
But that, I like the look of that one. Yeah, let's try. No. Do I not? Maybe. 5 sine squared. Suppose we didn't, did we? All right. I'll do it. Oh, they do. Sorry. Man, they like that a lot. Yep, let's try the top one, question 9.
Okay.
Just gonna save this.
So would tan squared x minus 2 be a squared x minus 2?
A is tan x, so you shouldn't have tan or x.
Yeah, so would it be a squared x minus 2
You
for the
shouldn't.
first part?
You shouldn't have any x.
Oh, just a squared minus 2.
What's tan?
A.
Yep.
Minus 4.
Yep.
Equals 0. And then could you put that into the calculator?
Yeah.
So x is minus 3 and x is 0. I put into the calculator a squared minus 2 and then a minus 4, or 1 minus 4. Is that right?
Not sure. 1 sec. So 1 equals minus 2 equals minus 4. Nope. So this one, see this one here, a squared minus 2a minus 4.
Yeah.
What is a, what is b, what is c? Little a, b, and c.
A is 1, B is... Would B just be minus 2A minus 4?
B is minus 2.
Okay. And C is minus 4.
Yep. Let's put that in the calculator.
Okay. I got 1 plus square root of 5 and 1 minus square root of 5. So plus or minus square root of 5.
That's it. Okay, what's next?
And then we put back in tan.
Yep.
So tan equals 1 plus square root of 5.
Tan
Or tan. Oh, tan x, sorry. Equals 1 minus square root of 5.
Well done. And that's what you were asked to do. That's part A, get tan x.
Yeah.
Part B, solve.
Okay, and then you do inverse tan. So the first one will be 72.828 degrees for tan x equals 1 plus square root of 5. And then for minus square root of 5 it would be minus 51.027. And then this is tan, so can you plus 180 to them?
Okay. Yep.
Okay. So for minus 57.027, it can be 128.0.
Say 027.
Okay.
Yeah, you're right. Actually, I don't think there's anything that needs to be, because it's not tan 2x or anything. Yeah.
Yeah.
So we can do them to 3 sig fig, I think.
And then for the other one, it can be 252.828 degrees.
I think we can do 0.8.
Okay. And then we can do it again. Wait, can we plus 180 again?
Yep.
So you can get 308 for the right side. For the left side, you can get again 432.8 degrees. And then you can plus 180 to the right side again.
So 488, I think.
Yeah, 488. And then 400. And then that's the maximum you can go up to, and it will go over.
And so, answers for x.
X can be minus 57 point, just 50, no 51, sorry.
No. Range?
Oh, 0, okay. Answers can be 72.8 degrees, 128 degrees, 252.8 degrees, 308 degrees, 432.8 degrees. Or 488 degrees.
6 answers. Let's see. 72.8, 129. So they rounded to 129.0. 309.0. Did something round wrong on the other one? You said it was 128.0. Are you sure?
Yeah, that's what I got. I could add it again. Wait, minus. I got 128.973.
That's very close to 129.
Says 129.
Yeah, 129. All right. Grant, we have the idea. Good. Okay. Any questions there?
Nope.
Yeah, let's just go back. There won't all be this straightforward, maybe to call it. I'm gonna see if there's a simpler one. Yeah, let's try the bottom one.
Okay. The 5B, right?
Let's try A as well.
Okay.
I've moved it to the top. Hang on. I don't like it. Let's swap. This one, sorry.
Okay. So would you need to convert one of them into the same, like, trigonometry value, like
Yep.
sine has to become cos?
Yep. How would you do that?
Would it just become 8 brackets 1 minus sine?
Yep. 1 minus.
Sine x.
Well.
Oh no, cos x, sorry.
Something's missing.
Squared.
Yep. 1 minus cos squared x.
Yeah. Plus 6 cos x minus 9 equals 0. And then we'll just multiply everything in the bracket of. Okay. So it'd be 8 minus 8 cos squared x.
Yep.
Okay. And then can you let cos be a?
Yep.
So it'd be 8 minus 8a. Would that be right?
Something's missing. Cos x is a. Cos squared x.
Squared.
Yep.
Plus 6a minus 9 equals 0. Would that work if we put that into the calculator?
Needs to be a bit simpler.
Okay. Could you need to minus 8 on both sides?
No. 8 minus 9.
Oh, minus 1.
Yeah.
So it'd be 8a squared plus 6a minus 1 equals 0.
Yes. And from there, I think you'd be fine for the rest of that question. You'd go through the full thing. Great. So in that case, let's try this one.
Okay. Should I do A first?
Yeah.
So do you need to convert cos into sine?
Yep.
Okay. So it'll become minus 3 brackets 1 minus sine squared x equals 1.
Yep. And then you'll be fine for the rest of that. It'll become 5 sine squared x equals 4 eventually. Part B.
Okay, so we have 5 sine squared x equals 4. So would you divide by 5 on both sides?
Mm-hmm.
Okay. So it'll be 4 over 5 on the right equals x and then sine squared. And then would you square root both sides?
Mm-hmm.
Which gives you sine x equals 2 square root 5 over 5.
And is there another similar number that when you square it, you also get 4 over 5?
Minus 4 over 5.
Yeah. So you could write it.
Oh, yeah.
You could write it as plus or minus. I'm going to write it because we still have more work to do as a separate thing.
And then can you do, for both of them, inverse sine on both sides?
Yeah, and from there you solve basically.
Yeah.
I think you'll be fine for the rest of that. So you did the important bit. And so, yeah, bunch of stuff, because it's so long doing these. Let's see this one. Oh, there's 2. I saw a real tricky one. Oh, it's a bit tricky. Let's start the top one here.
Okay. So would you need to minus cos on both sides?
Let me think. Okay, yeah.
Which would give you sine squared x plus 1 minus cos squared x equals 7 over 2.
Oh, no. 7 over 2 is times cos squared x.
So would that also be on the left, or would you need to divide?
So that'd also be on the left.
Okay. Okay. And then you can make sine cos. So it'd be 1 minus sine in brackets
No.
squared x.
No.
Would that not work because there's no number to multiply it by? So would you make cos sine?
You said you're going to make sine squared x into cos?
Yeah, so it'd be 1 minus cos squared x.
Yeah. First time you said 1 minus sine squared x.
Yeah, I got lost in my words.
That's all right.
Cos squared x. So 1 minus 7 over 2 cos squared x equals 0. And then could you just would you do 1 add, could you do 1 add 1, or would that not work?
Yep.
Which would give you 2, so it'd be 2 plus, then you could just, yeah, minus cos squared x plus 2 minus 7 over 2 cos squared x equals 0.
Mm-hmm.
And then could you make cos squared x a?
Yeah.
Okay. So I got minus a plus 2 minus 7 over 2 a equals 0. Oh, squared, sorry. The a's is both squared.
Okay.
And then could you minus the 2 from the 7 over 2? Would that not work since they're multiplying by cos squared or a squared?
You can combine the two a squareds.
Would that just give you 2a squared?
It would be like, so if you have minus a squared, that's like minus 1a squared minus another 7 over 2. And so minus 1 minus 7 over 2.
So it's minus 9 over 2.
Yeah, 2 minus 9 over 2a squared.
Okay. Oh, because you multiplied this minus 7 over 2 by minus 1.
Added them together.
Added them. Okay. Equals 0. And then would you minus 2 on both sides?
Yeah.
Which gives you minus 9 over 2 a squared equals minus 2.
Mm-hmm.
And then would you do inverse of cos? Oh no, not yet.
Not yet.
Could you square root both sides?
Not yet. You have to get a squared equals.
So would you add minus 9 over 2 to both sides?
It is currently...
Oh, divide, sorry.
Yeah.
Oh no, wait, yeah, divide. So it'd be minus 2 divided by minus 9 over 2.
Yeah.
Which gives you 4 over 9. So a squared equals 4 over 9. Then you'd square root both sides.
Yeah.
Which gives you 2 over 3. So a equals 2 over 3. And then you convert a back, don't you? Actually, no, because you want the solutions, don't you? Of cos.
Yeah.
So you do
Hold on. Slow down. Is there another similar number that when you square
minus.
it? Yeah. So a is 2 over 3 or...
Minus 2 over 3.
Yeah. You'll be fine for the rest of that. That's the bit I needed to check. You still didn't get it. Let's see. But that's good. That was on different sides. So then you'd have to go through...
Would you still get the mark if it was plus or minus 2 over 3?
Well, let's just Let me just find where our previous one was. Where was it? We did loads for like tan or something. So this tan one was, we had 1 plus root 5 and 1 minus root 5. So it was like 1 plus or minus root 5. The first one gave us 3 solutions. The second one gave us 3 solutions. And so, you know, you would get half of the answers.
Yeah.
If you included only the positive one. So like 2 over 3 might get you 3 answers. Negative 2 over 3 might get you another 3. And in total that's 6. Or it might be, you know, 4 solutions. But if you use only the positive, you'd lose like half of the answers basically.
Yeah.
Yeah, so there were 4 answers in total. Using the positive only, you'd only get 2 of them.
Yeah.
Okay, let's see. Alright, how do we start this one?
Okay. Would you need to minus 3 sine squared x on both sides?
Okay.
Which gives you 2 cos squared x plus 9 sine x minus 3 sine squared x. And then could you convert cos into a sine?
Yeah.
Which gives you 2 brackets 1 minus cos squared x. Oh, sorry, sine squared. 2 brackets 1 minus sine squared x close brackets plus 9 sine x minus 3 sine squared x. And then you multiply 2 by the bracket, the stuff inside the bracket, which gives you 2 minus 2 sine squared x plus 9 sine x minus 3 sine squared x. And then I don't think there's anything you can simplify.
Sure is. We've got 2 different sine squared terms.
Oh yeah. So would you convert them to a first, or would you just simplify?
Whichever you prefer.
So would you minus 2 sine x squared from minus 3 sine x squared?
Yep. What do you get?
Minus 5 sine x squared.
Yep.
So it'd be 2 minus sine x sine squared x.
Hold on.
No,
Hold on.
5 minus 5. Wouldn't it be 2 minus minus 5? Or would it just be 2 minus 5?
Just minus.
Oh yeah, because the minus is on that. Oh yeah, okay. 2 minus 5 sine squared x plus 9 sine x equals 0.
Yeah, and because it's like that's exactly the same as the previous one. The minus 1 minus 7 over 2. Minus 2 minus 3 gives you minus 5.
Yeah.
Okay.
And then would you let sine be a?
Yep.
So it'd be a minus, no, sorry, 2 minus a squared plus
Something's missing.
9a equals 0.
Something's missing in there.
Oh, sorry. 2 minus 5a squared plus 9a equals 0.
Yeah.
And then would you put that into the calculator?
And so what goes where?
Okay.
What is A? What is B? What is C?
A is minus 5.
Yeah.
B is just 1. Oh no, 9, sorry.
Yeah.
And C is 0.
No.
Would it just be 2?
Yep. The number without A.
I got X can be 1 or X can be minus 1 over 5.
What do you be putting in that calculator? Was the first answer X is 2 and you just said 1?
Wait. Yeah, it's 2.
Okay.
And the next one is minus 1 over 5.
Minus 1 over 5. Okay. 1 second. Okay, what would you do next?
And then you would... So A would be equals 2 or A equals minus 1. And then you convert them back to the A back to sine.
Yeah.
So it'd be sine X equals 2 or sine X equals minus 1 over 5.
Try
And then you
solving.
do...
Try solving that first one.
Okay. So would you do inverse sine too?
Yep.
Which is a math error.
What's that about?
Is that to do with
Sine graph. What's the maximum? What's the minimum?
Oh, that's what I was about to say. Yeah, the maximum's 1, so it can't go above 1.
Yeah. And
Minus
so
1.
that one's outside the range. And so you would just solve the second one, and you'll be fine for that. Let's see. This one. Yeah, they got sine X. Yeah, great. What was weird about this? What was weird about this? That was plenty weird. Okay, let me see. Fine. Very fine. Oh, yes. All right. How do we do this?
Okay. So you could make it cos A first.
Yeah.
2A squared plus A minus 6 equals. Okay, and then you put into the calculator. A is 2, B is 1, and C is minus 6. Wait.
What does it say?
It says X is 3 over 2 and X is minus 2.
You are something else. 2 equals 1 equals minus 6 equals. Yeah?
Oh, it's minus 6. Oh, wait, I put minus 6 in. Wait. 2x squared plus 1x minus 6.
Mm-hmm.
Yeah, that gave me 3 over 2 and minus 2.
Wait, what? Ah, yeah. No? Yeah. Okay. That's not as... It's weirder than I thought. Okay, 3 over 2 or... Wait.
Minus 2.
Sorry, this is A, not A squared. A is that, or A was minus 2. Okay.
And then you convert it back to cos x. Cos x equals 3 over 2. Or cos x equals minus 2. Then you do inverse cos on both sides.
Yep.
So the first one's a math error.
Yep.
And the second one is most likely going to be a math error. Yeah, it's a math error.
Yeah.
Because they're both above 1. Because 3 over 2 is 1.5.
basically cos x is in between 1 and minus 1.
Yep.
This one's too small. This one's too big. Therefore, no solutions.
Yep.
Good. So that's not what I thought it would be. I wasn't expecting any solutions or anything even close, but we got it. Show
Yep.
that this equation can be written like this. I think that's okay. Let's see. That's fine. Okay. Equations and identities.
Probably between a tick and a half.
Hey, great. Let's see. And yes, so we finished that chapter. Okay. Let me just check. So this one, how else can you write tan?
Tan can be written as sine over cos.
Yeah, tan x is sine x over cos x. Tan 2x is sine 2x over cos 2x. Tan squared x is sine squared x over cos squared x, etc.
Yeah.
And then you can rearrange. Let's see. Equations and identities. Yeah, you let like cos theta, sine theta, tan theta be equal to a. Solve it normally because that helps, and then just swap it back at the end.
Yeah.
You have lots of combining to do. There's lots of swapping between sine squared and 1 minus cos squared, or cos squared with 1 minus sine squared. Lots of it. Lots of it. When do you not get solutions?
When the number that a is equal to is above or is either too big or too small than the range of 1 and minus 1, which is the graph.
Yep. There was another thing I was expecting, which is like a quadratic that can't be solved. Like I thought it would give like b squared minus 4ac is less than 0, but it doesn't seem like they mind that one. So this one, tan x, was that? Yes. Just try to remember plus or minus. You get your, when you square root, that you get two separate answers.
Yeah.
Yeah, how was that for you, Adam?
That was good.
And so, when is our next lessons or something again? Oh no, we figured out our Christmas lessons, didn't we?
Yeah, but my mum said she doesn't want it on Monday because I think we're doing something on Monday. So do you think we could change that now?
Yeah. Let's see.
Okay.